We have a pretty funky looking integral here. We don't know how to integrate it in its current form, so you might think that you could use a u-substitution. And you'll notice that if you choose a u equals sine of q, then du would be cosine of q dq, and that cosine of q dq appears right here in the integral. So that substitution is going to work for us. It's going to simplify things quite a bit here. We're just going to end up with an e to the u du. So maybe we can discuss what our limits turn into. Our limits of integration on q in this problem go from 5 pi over 2 to 3 pi. So when we change all of our variables over to u, the lower limit is going to be sine of 5 pi over 2. Just using this formula right here and plugging q equals 5 pi over 2 in. Let's see, if we remember our unit circle, this is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. 5 pi over 2 is coterminal with pi over 2. We're calling some of that old lingo. And the sine of 5 pi over 2 is just 1. Now when q is 3 pi, our u is going to be sine of 3 pi. And going back to the unit circle again, pi would be here, 2 pi would be here, and 3 pi would be over here, coterminal with pi. And the sine of that angle is just 0. So when we change our limits over, our lower limit of integration is going to be 1, and our upper limit of integration is going to be 0. Let's do it. We have our new limits of integration. We have an e to the u, du is our integral, which integrates very simply to just e to the u, evaluated from 1 to 0. Plug in our upper limit of integration, subtract, and plug in our lower limit of integration. That's going to give us 1 minus e as our answer, and I think that's pretty good. Super fun problem there. These keep getting better and better. I'm looking forward to the next video.